So welcome back. Now we want to see whether the low risk anomaly also exists for total risk. It's a no-brainer, it does, because standard deviation is just total risk to the power of 2. But doesn't matter, we just do it. But we do some copy paste here to save some time. I want to plot inf op, that's all right. And I don't want to plot the standard deviation, but I want to plot total.risk. Is that the right name of the column? Total.risk. And give me the mean. All right. Oh, it did not annotate. plt.show. What's the matter here? Interesting. It does total risk versus the mean. You see again, it's a negative connecting line. Oh, I see. You see, copy paste is good. Correcting it is even better. Nice. Okay, great. So that's what we have. And again, you see, just the picture doesn't change. It shouldn't change because we just scale the x-axis monotonically. Doesn't change the relationship. Now, next picture we plot versus systematic risk, where systematic risk is measured by the covariance. Okay, so how did we call the x? Systematic risk, I believe, and then we have the annotation here, systematic risk. Okay, that picture looks even more dense, which means it tells me I already see that the R square is higher than here. Because here you see it's more widespread. If you put a straight line here, here it's much more dense. So it's good. We'll have a higher R square. We had one GLS video on standard deviation as a risk factor. The R square was 11%, so maybe that is then here 20. We come back to it, I think, now that I talk about it. We could have another video for that. Let's just redo the same picture, but instead of systematic risk, we normalize systematic risk by market risk. That's the CAPM beta. So I think I just called it here beta. So the picture should be exactly the same shape. It should also have the same R square, because we just normalize all of the variables by the same market risk. Boom. It looks very similar. Kind of. I love it, right? So there is not just a low risk anomaly here, there's the contradiction of the CAPM. High beta stocks tend to underperform. That is well known in literature. Since the beginning of the CAPM, there has been research by AQR about that investors prefer leverage in their stocks. And that's why they prefer to buy high beta stocks, which makes the price go up as the supply is fixed, but demand goes up, which if the price goes up, price equals cash flows over discount rate, meaning the discount rate goes down. So much that the CAPM relationship inverts. That's a theory. There are empirical papers which I find very interesting about if you use high frequency data to compute betas, the relationship becomes positive. We should really do it. I just don't have the high frequency data for now. And there's also research about if you use option data to back out the beta, the relationship is positive. That has been done with US data, not with European data, I believe. Yeah, US data. So maybe we do it. I mean, motivate me, right? If you send me some motivating stuff, then why don't we do it? Because we have the data. Just takes a longer video. Okay, great. So you see the market has a beta of 1. And as you increase the beta, all else equal, you are reducing the return. That's an anomaly according to a theory. It's a Nobel Prize theory, so it's not easy to throw the theory away. And again, there's data evidence that just what we do here is a rather rough, right? And if you do it really precise, using better data, suddenly the relationship inverses. But for now, when we look at the data, negative relationship for systematic risk. And the last picture for now would be the idiosyncratic risk. That is this Andrew Ng, Bob Hodrick, and co-authors paper. They identified first that firms with high idiosyncratic risk, which according to the CAPM should not affect returns on average, they found it correlates with returns, with average returns in a negative way. So just want to make sure I get the column name right. Here, just plot that thing, plot there. Ah, don't do copy, do a paste. Copy, paste. Okay, so you see, there's an imaginary regression line going through. It would still have a negative slope. Firms with higher idiosyncratic risk tend to earn lower average returns. The market portfolio has no idiosyncratic risk. It's a finance learning point again. Market risk equals systematic risk. Okay. All right. So you see, low risk anomaly for all risk metrics that I could come up with here in terms of volatility. And that's for the moment everything.